Welcome to Physics Concepts, Lecture 4. Today, we will explore Newton's second law of motion. Let's dive in and understand the principles behind it. First, let's define some key terms. Mass is the quantity of matter in an object, reflecting its inertia. Weight is the force due to gravity on an object. The kilogram is the fundamental SI unit of mass, equivalent to the mass of 1 liter of water at 4 degrees Celsius. Consider an anvil in outer space. It may be weightless, but it is not massless. An astronaut finds it difficult to shake a weightless anvil in space, just as it would be on Earth. The more massive the anvil, the harder it is to shake. Inertia is the property of things to resist changes in motion. It is a fundamental concept in understanding how objects behave when forces are applied. Why does a slow continuous increase in downward force break the string above the massive ball, but a sudden increase breaks the lower string? This illustrates the concept of inertia and how it affects the response to forces. Force is any influence that can cause an object to be accelerated, measured in newtons. 1 newton is the force that gives an object of mass 1 kilogram an acceleration of 1 meter per square second. Volume is the quantity of space an object occupies. When you kick a ball, it accelerates. This is a practical demonstration of Newton's second law. Force equals mass times acceleration, or F equals ma. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The greater the mass, the greater the force needed for a given acceleration. The force of a hand accelerates a brick. The same force accelerates 2 bricks half as much, and 3 bricks a third as much. Acceleration is inversely proportional to mass. Friction is the resistive force that opposes the motion or attempted motion of an object past another with which it is in contact, or through a fluid. A crate slides to the right because of an applied force of 75 N. A friction force of 75 N opposes motion, resulting in zero net force on the crate, which slides at constant velocity. Free fall is motion under the influence of gravitational pull only. Terminal speed is the speed at which the acceleration of a falling object terminates because air resistance balances its weight. A heavier parachutist must fall faster than a lighter parachutist for air resistance to cancel his greater weight. This equation shows how net force and acceleration are calculated. A stroboscopic study shows a golf ball and a styrofoam ball falling. Air resistance is negligible for the heavier golf ball, but significant for the lighter styrofoam ball, which reaches terminal velocity sooner. Thank you for watching. Please like, share, and subscribe to this channel. Add a comment below the video for the benefit of other viewers. What did you learn from the video? What topic would you like to explore further? Fair use disclaimer. This presentation contains copyrighted material used under the Fair Use Doctrine for educational, commentary, and research purposes. All rights belong to their respective copyright holders. Links are provided in the video description to relevant resources.